Oh,
Okay.
all right.
Please begin.
Okay, so hello everyone. So we're delighted to have the first invited talk of this conference. Aside from yesterday's talk, which was a distinguished lecture, so a bit different. So we are very happy to have Professor Sako from Waseda University, who will talk about cryptography for a secure, privacy-respecting, and fair society. What more can we do? So Professor Sako was a researcher for NEC for a long time. She's a long-time member of the ISCR community. In particular, she and especially the Azure Crypt community. She has been program co-chair for many ISCR and other conferences, and including RWC recently, a member of the RWC steering committee recently. And in Japan, she has had a number of government-related responsibilities, so responsibilities in various government committees for identity, privacy, authentication, so on. So concrete application of applied cryptography in the real world in some sense. And so this will be very related to the invited talk she will give today. So very happy, very honored to have you, Professor Sako, and the floor is yours.
Thank you very much for the kind introduction. I am very happy to have this opportunity to talk to you at Azure Crypt 2021. And Azure Crypt 2021 is very special because that's, well, 30 years ago, back in 1991, that was the first time a conference titled Azure Crypt was held. So this is 30 years anniversary sort of for a conference titled Azure Crypt. And that was held in Japan. And if you look closely under the organizing committee, you will find my maiden name, Kazue Tanaka from NEC. So I was very enthusiastic to have this Azure Crypt 91 happening in Japan for the first time. And me at that time, I did not expect me after 30 years will be talking to you like this in the same conference, Azure Crypt. So today, as Mehdi said, I will be talking about what cryptography can do for our society. And all these 30 years, I strongly believe that cryptographic protocols are designed to bring more security, privacy, and fairness to society. And today, I would like to share with you my journey so far, trying to achieve and accomplish this goal. And actually, this talk is more intended to talk to students learning cryptography, to tell them that there are so many anticipation from society to you, and you have lots of things to do after learning cryptography. So there will be, this is not a technical talk, and I don't think you will see any math in my presentation today. So my journey so far. Well, as you can see, I'm in this field for more than 30 years. And my first try being in a company called NEC, what I did in their project for the first time was implementing RSA crypto system using a special processor called digital signal processor. So you have to bring yourself back to more than 30 years ago. That time, computers were very slow. And for RSA of like 512 bits long took very long. If I remember the figures correctly, it was like an hour for a personal computer to do the job. So there weren't any applications of public key cryptography, and people read and learned about RSA cryptosystem. They loved it, but they sort of thought it as a dream. It will be nice if it come true someday. But with this DSP that I designed, now I think it computed RSA cryptosystem of 512 bits in several seconds. So that's really good compared to ours. So, and they used it in NEC's product. And that was for prepaid card. So at that time, remember, 40 years ago, prepaid cards were worth something around $10 because it was easy to modify the amount. So they have to keep the amount limit low. But they wanted to have this prepaid card used in other applications. Well, so if it was phone call, yes, maybe you will not lose much if this card was misused. But they wanted to have more prepaid card with larger amount. And for example, they wanted to use the card that could be worth $100 in riding a taxi or shopping or eating at restaurant. So my first project with NEC was to secure the remaining amount in prepaid card using RSA signature, and all the taximeter of our client had this DSP inside, so they can check the correctness of the prepaid card. And so that was my first success story. And what I really liked was I walked in the town and I saw people using the prepaid card that I developed, and they were enjoying it. So that was my first experience that indeed having secure cryptography module inside, people can benefit and enjoy a new product and new services. So, and after that, I worked on electronic voting protocols. I have some papers at Crypto and Eurocrypt on voting protocols. Again, I did not want to finish it just as a paper, but I wanted to implement it so people can use voting protocols that uses a mixed network. So again, this was another sort of success story that I did implement them. And they were, NEC's labor union used it for a low binding voting system, because labor union, we have a law saying that you have to do a legitimate voting to reflect every member's voice to elect their president or change the rules or collect the strike rate. So I think that was in early 2000. They started using it, and the labor union had like 20,000 voters, and I have not been told they stopped using it, so they are still using the system for I think more close to 20 years now. Well, so this was a big experience to me, because the issue, yes, the voting protocol was regarded to be very slow at that time, So making it faster was one of the things we tried, but many difficult issues laid outside the protocol. For example, how to authenticate voters, which PKI are we going to use? Uh, if if they want to implement voting protocols, voting system, but if the employees did not have PKI, they could not use it. And that was a big obstacle in spreading this kind of system. And there were some problems regarding the key management for the mixers where they should be able to have correct keys corresponding to the public keys, but yeah, that was a difficult part. And then my journey late 2000, I did more implementation of voting systems in real world, and one of the experience was I implemented this voting system for Young Researcher Award within this annual domestic crypto security conference in Japan called SCIS, where this is a big conference. We have each year like 600 or 800 voters. And then the first electronic voting using Mixnet was performed in 2008. Before that, we were doing the paper-based voting for this Young Researcher Award. So probably you would guess if we wanted to have a real rigorous voting system used in this size of community, the operation becomes more complex. And so I thought I should list some of the experience I had, which I think I mentioned some of them already. Well, so maybe cryptographers or people working on voting system would know what's the requirement on voting system, but people in general, even though they're engaged in the security conferences, voters didn't believe their vote is a secret vote. I mean, they didn't really care much about the secrecy of vote. And because in order to avoid duplicate votes, we asked them to authenticate themselves. So they would took for granted that, that was not encrypted, and then the server knows the vote. And actually, voters does not care much about the correctness of the tally. So even though we prepared the verification software for verifying the zero knowledge proof that the tally is correct, not much people cared about it. And key management. There was a big issue where they had two set of decryption key and a public key. And the first decryption, first pair was used for test, and then the second was for the real, but they sort of sorted, and after the real voting, when they tried to decode it, they couldn't decode it correctly because they only kept the decryption key for the test session. So we did the voting again. And the key management. So in this SCIS voting system, it was voluntary professors who served as a mixer to guarantee the rigorousness that these professors are not colluding. So so I asked them to do the setup, but the professor forgot to, well, they did the setup, but they just deleted all the files they had in their computer. So the decryption key was lost. So we had to set up everything again. So how to manage the keys, it's really difficult for usual people to understand. And then the last thing, this is the sad story. But after trying this electronic voting in SCIS for, I think, around 5 times, then the organizers got really tired of organizing it, a rigorous procedure for electronic voting. And they said, oh, why don't we use just cloud system and let them count the vote, and we trust the cloud. So they stopped using it. So yes, it's really difficult to find the need, what these people really want, by implementing the voting system. Maybe they didn't care much about the privacy. They just trust the cloud, and that could have been enough. So after going through implementation of voting system, so this is year around 2005. And if I look around, cryptography, especially symmetric keys or the secret key encryption system, are used very much, but public key cryptography was not being used. Maybe for a single system like voting system, we tried hard, but people thought it was too complex. And then the only two examples that I could see in the surroundings was using public key in SSL TLS and PKI. But as you know, those days we had a lot of fancy crypto protocols in the literature. And my next challenge was, how can we have more people enjoying the benefit of public key cryptography, like group signatures? I really like group signatures. It has a nice balance between security and privacy. So I really thought hard, how can I make it happen? So my first approach was, maybe we need a good business application for group signatures so people would like to use. I think all of you know what group signature is. It's a system where a user can prove its membership of a group, that they belong to a certain group, but without identifying themselves, revealing which member or the membership ID or anything like that. And it's a good balance between security and privacy, because you now enjoy the privacy, but if something bad happens, there is a designated opener who can revoke the anonymity and identify exactly who you are. So I tried to explain this to many of my customers and clients and people around me. And this is how I try to explain. So the group signature is, it is the same string of data that can mean different things to different people. For a verifier, this string means a confirmation of a membership and doesn't tell more. And for opener, the same string gives you the identifier of the user, right? So you have one string, and that means different things to different person. So with that, how do you want to use it in your business? So the first business application is the credit card scenario, where this Alice has a credit card, and this verifier at a store, he can check that this is a valid card, but without knowing more details about the credit card number. So he cannot misuse Alice's credit card. But if the same string that was transferred from the shop to the credit card company, now it's the opener, and this credit card company can identify Alice and can pay the amount Alice paid and send the bill to Alice. So I thought this was a fantastic scenario for using group signatures. Another scenario I thought was in library scenario. So Alice wants to borrow a book, and librarian wants to make sure if she is a registered member of this library. And if she returns the book in time, the librarian does not have to know who borrowed this book. But maybe if there is a overdue book, there is a manager at the library and only she can be an opener and identify who has the overdue book. Okay. So, and there is another scenario, it's a passport scenario. And whenever I travel, when I go to hotel, this hotel clerk says, show me your passport, and they will take a photocopy of it. But do they really have to know my passport number before anything happens? So maybe I can use group signature so that this hotel knows that I have a valid passport issued by Japanese government. And if something bad happens, or I didn't pay the hotel bill or something, they can go to the Japanese embassy, who can be an opener and identify myself. And then the last scenario is not really Alice, but in car scenario, when cars are talking to each other, like I'm turning left or right or braking or those kind of messages, and someone, some car next to it is going to get the message so that they won't hit each other. But when something bad happens, there could be an opener to identify which car was running where. So I came up with many different scenarios and hoping someone get interested and trying to use it. So how well did I do? So the credit card scenario, I was told, okay, so it's a nice protocol, nice feature, but we already have SET that does this job, right? Okay, so that sort of did it. And then the library scenario, I really went up to one of NEC's customer who is doing the video rental. And then what they said was, oh, do we have to set up a new server for this manager and this librarian? Oh, that would be too expensive. So that threw away my idea. And then the passport scenario, ICAO already had the standard to do the identification, and I could not sneak this kind of group signature in. And the last scenario, I thought, okay, credit card company has a long history, and so is passport. So in car scenario, and when we are talking about something new feature to cars, like electronic vehicles, if it's a brand new, then there might be a chance for me to sneak this kind of group signature algorithm in the standardization. And so they said, okay, let's work on a standard. Great. So actually, I did work on this electronic vehicle to grid communication interface, standardized at ISO 15118 in 2013, and talked to them how these, well, it was not really car-to-car communication, it's the electronic vehicle that wants to charge the power to the car, and how do they authenticate themselves to the grid company or the power company. So, and then they really cared about privacy. They did not want these power companies to trace the car when they charge energy in Paris and then move to a different city in Europe all the way to Italy, or, you know, they don't want to be traced. So there, I had an opportunity, but unfortunately, because they wanted to implement today, they did not want to have a new algorithm that no one implemented before in their cards. So they just used an ordinary PK, public key encryption system. So far I was not able to find any good business application. So, and then I thought what else I could do. And when I look at the success of PKI, I saw that now these TIPS computing RSA is now so tiny and small, they could be embedded in TIPS like this card. So maybe we would need a fast hardware that computes group signature so that a card can compute a group signature inside the card. So what I did, so this is my slide back in 2010 when I gave talk in NIST workshop. So I reported, we developed the world first, to our knowledge, LSI for group signatures, where inside the tip they have all the accelerators for ECC and RSA and hash functions in a very small tip. Okay. So, and even though we had a tip, LSI, we didn't fly either. So I have to think of other ways. How can I make people enjoy this beauty of group signatures? And then my next approach was about standardization. Well, when I first went to this credit card company, SCT was a standardized protocol. And also for the passport, there is a standardization. And I also began standardizing in this electronic vehicle to grid conversation. So maybe I should be standardizing group signature, the basic group signature protocol, in a more general standardization body. So what I did was I joined this ISO IEC JTC1 SC27 group where they worked on information security, and especially this working group 5. The mission for this working group 5 was to work on identity management and privacy. So group signature would be a best fit to this group. So, but it was really a different community at the first time. So they use terminology that's somewhat familiar, but they used it in a different meaning. And identification, authentication, authorization, in credentials, and anonymity. So I first had a difficulty understanding what they really meant, like credentials. And when I talked about group signatures and said, this is anonymous, and they said, no, you don't call this anonymous. So what it ended up was the group signature was renamed to be partially anonymous, partially unlinkable authentication. It's okay as long as I could standardize it. And in 2012, this standardization document number 29191 gives a framework for doing this group signature scheme in user authentication. And then this working group 2, who is working on crypto mechanism, also came up with more detailed mechanisms and algorithms for group signatures. And what was, even though I had a hard time at the beginning, I thought this activity was very good. And because for these following 4 reasons. So I could meet people who is looking for alternative solutions. So in this working group 5, people were working on how to do identity management well and protect people's privacy. So they were always looking for solutions that does it better. So when I first explained to them about this group signature, and I still remember this one of the members saying, what you're saying is too complicated. You're confusing me with authentication and authorization. And can you explicitly say which part is authentication and which is authorization? Right? So they had in mind that when you want to do authorization, you first have to do the identification and authorization, authentication, and then authorization. But group signature is a kind of a module that only gives the group membership. And that's something like authentication, that you belong to a member, but that's something like authorization, that some group is authorized to do something, so you want to authorize that. So, but talking to someone who is not your field really helped me to brush up how should I explain the technology well to the others so they can understand. And also, it helps me understand the technology more, because now you can think about how people want to use group signatures, and they might want to use it for authentication or authorization, and I should be able to speak the language so that they can understand what this technology is doing. And then the third point is I can learn about related technologies used in real world. So these people working on standardization is really implementing the real world identity management, and they really care for privacy. So I could learn about the current technologies used in identity management, like OpenID Connect and all those things. And then I am compelled to explain the difference between this kind of anonymous authentication protocols and these OpenID Connect protocols that tries to preserve a privacy for users. So I am still struggling with this, but it's a different model, but I should be able to explain the differences to the people so that people can make right decisions which they want to use. And what is good about standardizing technology is that if we were successful in making a developer-friendly specification, then there will be developers writing codes for the technology, and then people would instantly use, well, it's much easier for them to deploy those kinds of technologies. So I think if we want to have our technologies, if we want to have more people using our technology, standardization, it's something we should carefully look into and do it well. Okay, so after all these journey, and then I also did some consulting for for the products in NEC. So I now have a lot of experiences. What is the good design and what is the bad design, and what are the things we should be careful in advance when designing these kind of systems. So I was wondering, how can we share these experiences? And because I know I had hard time designing the system that these users have very peculiar requirements, and I really try to meet up their requirements, and I wanted to share that. And I also wanted to learn from the others because they have done it better than I did, right? So I really wanted to find a place where we can share this kind of experience. So that was the reason I, with Aguilas Quielles, started a workshop on real life cryptographic protocols and standardization. So it's like I put two things that I'm interested in to a name of the workshop. So how can we have cryptographic protocols in real life? and how we can do it good in standardizing them so people would use it. So this lasted for 2 years, and it 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 didn't last. And then probably because maybe I'll have it in the next slide, but I still don't know how to make this kind of workshop successful. And if you have any ideas, I'll be very happy to hear it. But I hope I can try to explain what I want to say in this slide. Well, let's say these yellow dots are examples of some primitives, like say a digital signature scheme. So if you look from the efficiency and then the security, there are different kinds of digital signature schemes that has been proposed. And the way we are used to in evaluating the new digital signature scheme is that either it's more efficient than the previous algorithms, or is it more secure than the previous ones? So those algorithms that comes to here is easy to be accepted at conferences like AsiaCrypt and PKC and all those conferences. But if you're thinking about implementing, for example, digital signature, it's not, they do not fall into the world best efficiency or the world best security. It could be somewhere lying in here because of other requirements needed in real life, like there is a hardware limitations or the development time limitations. So even if we were trying to come up with a good signature scheme that is good for implementation, it is hard to be accepted in conferences because it's difficult to convey why this product algorithm falling around here is worth publishing. And it's the mindset of the reviewers also. And but as a community as a whole, we don't know, and I don't know how to evaluate those signatures that falls around here. And also, when you're designing a crypto system, it's the combination of goods, for example, good secret sharing scheme or commitment schemes and signature scheme, and all of these schemes need to be harmonized to meet the specific use case. But also, it's very hard to have this kind of paper in a conference because it's easy to say it's just a combination of non-technology, and that is indeed true. But when you're designing crypto systems for the real world, that's what we are doing every day, and we are looking for the best combination, and there is no way to evaluate which combination was good over the other combination. And that kind of knowledge, it's something we need to collect for the community. So as I said, I think we need to learn how to write papers that shares our experiences in designing crypto systems. And as a reviewer community, we need to learn best practices or the best criteria to evaluate those papers, which I think is still lacking. Yeah, and this is another slide from my presentation in 2012 in a workshop after AsiaCrypt. And the subtitle of my talk was How to Become a Good Cook, because I think designing crypto system is like becoming a good cook. You pick the best ingredients and you have a recipe, and then you have the goal is to have a very harmonized, nice dish. And then I thought this, how to write this kind of recipe is an example of sharing the experiences and good practices so that someone who came in later can read the recipe and revise the same nice dish. So as I said, the best practices to write good recipe it's still in need. And also, I think this is still true. We need permission from our customers to write a recipe about the real life systems. And many of the customers hesitate to publish this kind of recipe because if they disclose it, there might be some security risk for disclosing it. Actually, I wanted to talk about another of my success story, which I really loved it because everybody enjoyed the product that I built. But the customer says, oh, please don't talk about us. So it's unfortunate I won't be able to tell here. But the story is I really have an experience that there's a system that uses public key crypto system that everybody is benefiting from that function. And I just wanted to share that I really loved reading this book by Ross Anderson titled Security Engineering. It's a very thick book. It's over 1,000 pages, and this has been published last year. But I thought this is a very good way of sharing experience. And he writes a lot about what kind of things he designed or what kind of things that didn't go right. And it's about security engineering. So I'm looking forward to find a place where we can talk things like this and share. This book is only about Ross's experience, but many researchers or many engineers share their experience on cryptographic protocols is what I'm looking forward to. And after the conference, the workshop of real life cryptographic protocols and standardization, yes, we have real world crypto system that collects many attendees. And also I really like this conference, SSR, Security Standardization Research, where they look into the standardization of the security technology. So I'm really happy to see this community is growing larger. And if you know of any communities that I don't know, I'll be very happy to learn about those. And until here, my journey was thinking bottom up. That is, I started with cryptographic protocols and I try and design it to fit to the society. But I started to think maybe I should be thinking top down. That is, starting from society and what kind of nice service or system we can have, and to that, what kind of cryptographic protocols we can use. This top-down approach was happening to me when our client came up to us and said, I want to do this, how can you do it? And then I could design using, I could find cryptographic protocols to meet that requirement. But it's all the requirement from our client, it's what they wanted to do. So my question now is, what do I want to do to improve the society? And then I came up with one difficulty I had. I was very angry at it, that looking at the society, why do we have to manage so many passwords for ourselves? And I thought this was the infrastructure problem, that the companies, they just give us ID and password and let us manage the password so they can be free of risk. And if something bad happens, they can blame us that you didn't manage your password correctly. So I think this is the architecture problem. So why do we have to use given ID and passwords for the different password for different services. Can we use just one or small number of public key that's common to all or many services? Just like my name, I'm not changing my name for every services. To me, Kazue Sako is this consistent name for taking all the services. And but also, if I keep on saying the same identifier, same name or same public key, then I can be traced. So can we sometimes hide a public key, but still prove that I have the right attribute to receive the service? And then I met this notion of self-sovereign identity, so that identity is sovereign. I can choose my identity. And then on top of it, people add attributes to my identity so that I can use that to prove my attribute. So that is currently being standardized in a World Wide Web Consortium as DID and VCs. DID stands for decentralized identifiers, and VC stands for verifiable credentials. So there are many people working on to make this come true. I do see some criticism against their approach, but I think this is an important step to move the society forward. And then the verifiable credential is a little bit funny name, because I always think the credential should be verifiable. But what they're trying to say is that the credential is something issued by a trusted authority, but using anonymous authentication technique or the group signature technique, you can hide some parts in the credentials, and still you can verify the content of the credentials. So I think that's where the name verifiable credential came from. So what I wanted to say in this slide, so there are many people trying to achieve this kind of a world, and in it they are using a lot of crypto technology in it and trying to standardize it. Okay, so now comes into 20s. That was all my work with NEC, but I moved to academics in last year because I thought I should now share my experience with students, hoping that when they are going to start their business in future, they can use cryptography freely. They can base new systems on cryptography. And when I left this private company, I was very lucky that many Japanese government offered me position or being a member of the government committee. So I work with Japanese government and I was going to say what I learned working with a cabinet secretariat or the financial service agency and even Supreme Court. They have high expectation on cryptography. One, because they also want to make their system secure, and two, they need to know the technology in order to regulate it, and they want to regulate correctly. And then the current law we have in Japan and probably in other parts of the world, it's so outdated that because all these regulations are based on physical objects like papers and ink, so they want to update their regulations and their laws so we can handle these things going on digital. So I am very happy to take part in it. And from there, conversation with them, I strongly believe that cryptography and cryptographic protocols play a big role in designing our society and enforcing rules in a transparent way. And now our challenge is what kind of design should we adopting, and what kind of laws to support this design need to be fixed. That's our challenge to consider. And we should all be in the conversation to decide about the design for the society. And therefore, I strongly believe sharing our experiences is very crucial. Okay, so with 5 minutes left, I will quickly run through the concluding remarks. Again, this talk was intended to students. I hope I can persuade you that your talent is really wanted in society for designing the society. So for future steps, 5 simple things. Discuss with people in other disciplines, promote good and useful standardization, and develop how to share experiences and collect good practices, design society using cryptography. And one thing I didn't mention very much, but yes, global interoperability is very important, and we have to think what's going on globally. But I think we all should also respect our local culture. This is Asia Crypt. There are many countries with different culture in Asia, and it's the people with the culture who is going to use the system. So even though the technology may be interoperable worldwide, but these interfaces with the humans, we really have to think about the culture, about the people who is using the system, and their perception is really important to have a successful society. So my last word, let's collaborate. Thank you for your attention.
Thank you very much, Sako, Professor Sako. So for the great talk. I'm sure there are probably many questions, even though I don't think, Kevin has a comment already, so I'm sure he can unmute.
Yes, I'd be happy to ask it orally. I think I was shocked in your talk by one thing you said, which was that people didn't seem to care that much about the trustworthiness of the outcome of an election, because this is a huge issue in the United States in the last presidential election. And there's been a lot of doubt cast on the process of voting now. So I wonder if you think that maybe people just didn't see the problem coming, or have you changed your mind about that?
Well, thank you, Kevin, for the great question. And I said culture is really different according to the region. And this is my interesting perception that when I give talk about electronic voting in US, just as you said, the correctness of tally is very concerning in people in US or in American continent. When I talk to people in Europe, they are interested in the privacy of vote, and they care much about how the privacy is protected in voting systems. And when I talk to people in Asia, they did not care much about the correctness of the tally or the privacy of the vote. I think they took for granted, or they very trust on the servers that they will do it good. And what their concern is how much efficient the system is going to make us. How many money can we save from using your system? That, yes, I think so. That's the difference in culture, and hope that answers your question.
Yeah, I think your talk was very interesting and reflected a lot of my own thoughts about the difference between working in industry versus working in academia. You've recently switched to go back to academia, and I actually started in academia, then went to industry to finish my career. And I guess some students will have questions about which is better to pursue. And do you have any advice on which do you think has, what the advantages and disadvantages of the different employment modes are?
Well, I only lived as I did, so I really can't compare. But I really enjoy working for a company because I had this experience of having my technology being used in society. And that was really important for me to continue this career. But at a certain time, making some product into society, that must come under the umbrella of a certain company. So that must be profitable for that company. So that was the time when I thought, I want to do what I want to do. So that's when I moved to academia. And now I can use any umbrella of the other company. So what I'm doing now is I can talk to any company to implement the new technology, hoping that would be benefit them. So I can change the company now because I'm in academia. I'm free to choose who to collaborate with. So like if you go to a company that's tied to one company, but if you're in academia, you have more selections.
Yeah, I once worked for IBM, and I wanted to do a project involving email, and I was told to go talk to Lotus about putting it into Lotus Notes. And I didn't have any freedom to choose who to work with at that time, so I dropped the whole project.
Kazue, I've got a question. So a lot of your talk was about, you very clearly said this is advice for youngsters, and that was really cool. But in some sense, the incentives for PhD students and the postdocs in our community are kind of aligned against doing stuff, like you said, you're doing the simple stuff which will solve a real problem. The incentives are more towards do something deep and complicated that no one's ever going to use because you're going to get your PhD that way, or you're going to get tenure that way, or you're going to get your postdoc that way, or whatever. So how do you think as IACR can change the culture and change the incentives for youngsters to actually, really engage with society, engage with companies, engage with real world problems, and maybe even just deploy a simple, come up with a simple solution to a complex problem rather than a complex one that will get a paper at crypto?
Right. I think I'm facing that problem. As I said, only the output that falls in either this pink and blue are accepted at the papers. So because it's IT technology, we shouldn't be sticking to this old paper-based evaluation. So I think the university must change, and right, we should be setting up some criteria. We should be serving for the society. That's I'm not sure if I want to offend someone else, but I think we have to change the criteria of evaluation, and how contribution we are doing to the society matters more than having more academic output, I would say.
Do you think that's something ICR should kind of like push to try and change the reviewing culture to make potential societal impact a greater component of reviewing papers?
I would be happy if some part of IACL would support this idea. But I still understand some people would want to keep more rigorous mathematical, more theoretical culture inside.
Yeah, so. I think all cultures, like you said at the end, it's not just cultures between APAC, EMEA, and North America. It's also cultures within the community as well. There's lots of different cultures we need to respect. So, but there should be room for everybody. Yeah, thanks. That was a really, really cool tool. Thank you very much.
Thank you very much.
Thank you, Nigel. I guess a tiny question is obviously to what extent do you see RWC as a success?
So yes, I do think RWC is a great success, but still the presentation slot is limited, and what we see there is the best of the experience. So I think when I was writing these slides, I thought maybe sharing these experiences could be more local, by region to region, by culture to culture. And then like RWC is going to be a big umbrella that it's sort of fostering that kind of a community.
Okay, thank you. I see Muhammad Usama Sarda has a couple of questions as well. Maybe you can unmute and ask. Oh.
Hello.
That's not working. Perhaps it's best to read his questions.
Okay, so his first question was regarding group signatures. Regarding group signatures, do you have any experience or thoughts about Intel's offering named Enhanced Privacy Identification, EPID? So I'm not familiar with this.
I don't think so. I know they were working on TPM and remote attestation protocol using advanced or the modification of group signatures. But I don't think I have enough information about EPID.
All right. And the second question is, can you elaborate on the point that you mentioned in the beginning that you said, so they said your approach was too complex and they decided to go for a cloud system. And in their approach based on the cloud, how did they ensure security or privacy? And so maybe you have some links to share. I'm not sure to what, but okay, so that's the question.
Okay, so thank you for your question. So, oops. Okay, so you have to think that this is 15 years ago, right? At that time, there weren't any, well, the cloud system wasn't so common. And what we did here in actual system is that you see these mixers here. So it's the professors who is running the system on their computer. And then what we did was there was an email from this professor to the next professor saying, this is the result of the mixed ballot. And now the second yellow mixer is going to shuffle and then pass it on to the next professor. And then they finally get the answer. So it included many manual operations. So that's why it was more complex. But we wanted to be rigorous and we didn't want to use the cloud because we as the planner, designer, did not trust the cloud services. But the people said to me, oh, it's just use the cloud server. That's more easier. And that's the more fashionable way to do IT. So I think that was the difference in views. We wanted more security and privacy, but the others wanted more ease of useness over security and privacy. Hope that answers your question.
Thanks. I guess that's still an issue in many cases. Okay, so I think these were all the questions. Again, we were very honored to have you giving an invited talk. And hopefully, if there are more questions, we can take them offline in Zulip or otherwise. And so we will reconvene in about 20 minutes for